At the center of most galaxies is one of the strangest and deadliest things in the universe, a black hole. So, what exactly is a black hole, according to NASA? A black hole is an astronomical object with a gravitational pull so strong that nothing, not even light, can escape it. At the heart of a black hole lies its event horizon, a boundary that defines the point of no return. Beyond this boundary, the gravitational pull is so intense that the escape velocity exceeds the speed of light, the ultimate speed limit of the cosmos. This means that once something crosses the event horizon, there's no turning back. It collapses into the black hole's singularity, an infinitely small, infinitely dense point where space, time, and the laws of physics no longer apply. But how do these cosmic enigmas come to be? Well, it all starts with the collapse of massive stars. When a massive star exhausts its nuclear fuel, it can no longer support itself against its own gravity. The star's core collapses under its own weight, triggering a spectacular explosion known as a supernova. If the core is massive enough, it collapses further, forming a black hole. Types of black holes. Astronomers generally divide them into three categories based on their mass: stellar mass, supermassive, and intermediate mass. But hold on tight, because there's a fourth type we'll touch on later. Let's break it down. Stellar mass black holes. Picture this: when a massive star runs out of fuel, its core collapses, forming a city-sized, superdense object known as a stellar mass black hole. These black holes are roughly 10 to 20 times the mass of our Sun and can be found scattered throughout the universe. We've discovered around 50 of them in our own Milky Way galaxy, and there could be millions more lurking out there. Supermassive black holes. Now, imagine a black hole that's not just massive, but supermassive, hundreds of thousands to billions of times the mass of our Sun. Almost every big galaxy, including our Milky Way, has one of these monster black holes at its center. The one in our galaxy, Sagittarius A*, is a mere 4 million times the mass of the Sun, while others can reach mind-boggling sizes of tens of billions of solar masses. Intermediate mass black holes. Here's where things get interesting. There's a mysterious gap between stellar mass and supermassive black holes that scientists are still trying to figure out. They suspect that collisions between smaller black holes over cosmic time should have created intermediate mass black holes, ranging from around 100 to hundreds of thousands of times the mass of the Sun. We've spotted some candidates, but confirming them is no easy task. And now for the fourth type, primordial black holes. These theoretical beasts could have formed in the chaotic moments after the birth of the universe. But so far, we haven't found any concrete evidence of their existence. Then, how do we find these invisible giants? Even though we can't see them directly, scientists have some clever tricks to figure out where they are and what they're up to. Well, scientists use a few different methods. One way is by watching how nearby stuff behaves. When a black hole pulls on a star nearby, for example, we can see the star's movements change. By keeping an eye on these changes over time, we can figure out if there's a black hole nearby and how big it might be. Another trick is to look for X-rays. When stuff falls into a black hole, it gets super hot and shoots out X-rays. Telescopes can catch these X-rays, giving us clues about the black hole's size and activity. And then there are gravitational waves. These are like ripples in space that happen when big things, like black holes, crash into each other. We've got special detectors that can pick up these waves and help us find black holes. Even though we've only been directly spotting black holes since the 70s, scientists have been thinking about them for a lot longer. They were first suggested about 100 years ago, thanks to Einstein's ideas about how space and time work. So, even though black holes are invisible, they're definitely leaving their mark on the universe. And with all these cool tricks, we're starting to uncover their secrets. First black hole discovery. Imagine the excitement when, in 2019, people all over the world marveled at the very first image of a black hole. And then, just a few years later in 2022, another image was released, this time of the supermassive black hole residing in our very own Milky Way galaxy. Now, here's the incredible part. These images are not artist drawings or computer simulations, they're the real deal. Here's the thing, black holes are incredibly far away, so far that even the most powerful telescopes on their own wouldn't stand a chance of capturing them. It's like trying to see something tiny from really far away, almost impossible, right? But scientists are great problem solvers. They came up with a clever plan. Instead of relying on one giant telescope, why not use many smaller ones spread out all over the Earth? It's like putting together puzzle pieces to see the big picture. This network of telescopes working together is what we call the Event Horizon Telescope. People who contributed to our understanding about black holes. As we journey through the cosmos, let's take a moment to reflect on the extraordinary individuals who ventured into the unknown to unlock the secrets of black holes. Albert Einstein. Hailing from Germany, Einstein revolutionized our understanding of the universe with his theory of general relativity. This groundbreaking framework laid the foundation for the study of black holes, revealing how gravity shapes the fabric of space and time. There are many more people who contributed to our understanding about black hole. For example, Stephen Hawking, Carl Schwarzschild,